Hi. Today we're going to continue talking about using matrices, but in this situation we're going to talk about translating polygons, in particular triangles, by using matrices. Now, from geometry, when we use the terms like translations, it's a type of rigid transformation. So we're gonna have a pair of congruent triangles when we're all finished with this. So that's what rigid means. The triangles will be congruent. But anyway, let's get started with this. I have an example of how to do this. We're going to translate. We're going to translate using matrices. Now, in this example, we have a triangle ABC where A has the coordinates -5, 4, -1, 5, and C is -3, -1. And I've actually graphed that over there so you can see what it looks like. And we want to find its translation matrix or figure, A prime, B prime, and C prime, if we move this triangle 3 units to the right and 4 units down. Now this is a pretty simple operation actually. We first of all want to write a vertex matrix from our original triangle. And so what that looks like is this. You put the x values for A, B, and C up on the top row, and you put their corresponding y values down here at the bottom row. And so you make what's called a vertex matrix. And so here I'm going to put -5 and 4, -1 and 5, and -3 and -1, the coordinates of my given triangle. Next to that, we're actually going to use matrix addition, which students usually find pretty easy to do. We're going to move, if the problem says move 3 units to the right, well, right is a positive x movement. And so to this matrix right here, we're going to add to it another matrix, which has to be the same size, same dimensions. If this is a 2 by 3, then that has to be 2 by 3 if we're going to add these. But we're going to put positive 3s across the top because it's a positive x movement. And across the bottom here, this says, and 4 units down. So across the bottom over here, we'll have -4s right there. Okay? This would be known as the translation matrix for our given problem. So this is our vertex matrix and our translation matrix. Now when we add these two things together, we'll get another matrix which will actually be the image of the problem. This particular vertex matrix is also called the pre-image. That's where we start from with our triangle, and where we're going to go is known as the image. So if I simply add 3 to these top x values, adding 3 to -5 gives us -2. 3 to 1 would give us a positive, -1 would be a +2, and -3 and +3 is 0. Subtracting or adding -4 to these bottom numbers would be 0, 1, and -5. And so we'd have these coordinates, and these would be the new coordinates, A prime, B prime, and C prime, and these would be coordinates of which is known as the image coordinates. Okay. Now, if I would graph these, -2, 0, -2, 0 would be right here, and we would label that A prime. 2, 1 would be over here 2, up there 1. This is where B prime would be. And C prime would be at 0, -5, which would be right down here, C prime. And if I connect those guys, and I realize I'm using freehand, but you can get the idea that this thing now is moved over 3 and down 4 units, just like our problem asked us to do. It's pretty simple. You just use matrix addition, and I hope that this helped you out.